Hey Team Electronics, welcome to your first screencast. A screencast is a tiny little lecture where I give you a note sheet in class, and then you watch a little video outside of class and it will connect to what we're doing in class, what we've done or what we will do in some way. So this is a short lecture on simple circuits. You should follow along and take notes as I talk to you. So we set up this circuit today in class, a little LED connected to our power and ground, as well as a resistor. And yeah, this component that we set up our circuit on is called a breadboard. The light is called an LED, and this was a resistor, and these are wires. Okay, whenever electrical engineers are setting up a circuit, they'll often draw it out in shorthand note, rather than draw it out like this analog to what we built. So the drawing I have down here is actually the exact same drawing as what is above, and so we're going to talk about what these different components mean. So first of all, these two dashed lines represent the battery. The battery has two sides to it. There is the positive side. Oops. The positive side. And for us, I don't want this to be filled. Style, fill, no fill. The positive side is 5 volts. In almost all situations in our class, we're going to be, the power supplied by our Arduino is 5 volts, and we're going to be using 5-volt systems. And then the other side is the ground, and we represent it as GND. This is also sometimes written, the 5-volt side, as VCC. And this is 0 volts on this side. So the battery has a positive and negative side. And this represents our wires here. Now, when we're setting up a circuit in Tinkercad or in real life, it's really useful to always use red when you're connecting to power and black when you're connecting to ground. Now, a red wire is actually exactly structurally the same as a black wire, but it really helps you stay organized to always use red on the 5-volt side and black on the ground side. So this, in our diagram, this would be our red wire, and this would be our black wire here. Okay, this component here represents our LED. Now, LED, here's a picture of an LED. LED stands for light emitting diode. And a diode is a polarized component. It means that the current can only travel in one direction. So our LED has a directionality towards it. This leg is called the anode, and it has to be connected to the 5-volt side, or the power side of the circuit. And this leg is called the cathode, and it has to be connected to the negative side. The negative side, or the ground of our circuit. So the long leg connects to the anode, the power side, and the short leg connects to the cathode. So you might have noticed in this activity that we did earlier today that if you connected the long leg here of the LED to the ground, the LED did not light up. It only lit up if you connected this leg to power and this leg to ground. Okay, so this is our LED in the circuit, and this squiggly line represents our resistor. Resistors come in all sorts of different strengths. We measure the strength of the resistor in ohms. Yeah, that's a bad ohm. Let me try again. The resistor that is in your diagram, the value of the resistor it's either 220 or 330. I can't actually remember which one it is. Now, a resistor, unlike an LED, is not polarized. So this means that we could rotate our resistor 180 degrees and plug it into our circuit, and it would function in the exact same way. So the LED, it matters which leg you hook up, but the resistor, it does not matter. It's an unpolarized component. Now, the reason we need a resistor in our circuit design is that if we didn't have the resistor, we'd blow up our LED. It would burn out. And the reason for that is that there's a relationship between the voltage, the current, and the resistance. This is called Ohm's law, where the voltage equals the current times the resistance. So in our system, we have a fixed voltage of 5 volts. But if we didn't have this resistor in our circuit, our resistance in our circuit would be very small. R would be tiny. And therefore, I would be quite big to have a 5-volt system. And this big current would blow out our LED. However, if we have the same voltage, but we have a larger resistance, we have a smaller current overall. So whenever you're setting up a circuit with an LED, it's important to use a resistor. You'll notice that if you use a big resistor, something with a value greater of, let's say, 1 kiloohm, then you'll get a really dim light. And this is because the resistance is big, and so the current flowing through the LED is pretty small. If you use a smaller resistor, you'll get a bigger current. Generally, we're going to use resistors with a value of 220 or 330 when we're setting up an LED. Okay, the last thing to talk about is the connection within the breadboard. The breadboard is a rapid prototyping device, and it's helpful for staying organized with your electrical connections. We call this and this the ground bus and the power bus. And they are both connected. So the power bus, every little well here is electrically connected to every other well in this line. And so they're electrically equivalent. So for example, if you bring 5 volts over here and you plug it into this power bus, there's another power bus on this side. Now all of these wells are at 5 volts. This is the ground bus. And the same thing, when you plug it into the ground, now they're all electrically connected to one another at 0 volts. When you examine the breadboard, so you use the power and ground bus to set up a bunch of circuits. Within the breadboard itself, the electrical connections are across, like so. So the electrical connections in the buses here are horizontal, but the electrical connections in the breadboard are, right now, the orientation is vertical. So for example, across this column 1, everything is electrically connected, but 1 is not connected to 2. Okay, this is a not true connection. Oops. And this connection is not true. These are true. This one and this one. There's also no connection across this well running through the center of the breadboard. So for example, row 1 on this side is not electrically connected to row 1 on this side. So in order to connect them, you'd need to jump a wire over like this. Whenever you're setting up a circuit, it's important that there is a complete circuit from 5 volts all the way back to ground. If you have an incomplete circuit, if there's some part that's not connected, that doesn't make a complete circle, then you don't have a complete circuit and your components will not work. If you directly connect 5 volts to ground, imagine you put a wire, let's say you took a blue wire and you connected these right here, you'd get what's called a short circuit. You'd have a connection between the 5 volts and the ground with no resistance. Imagine this resistance dropping down to close to 0. This would create a huge current, and your device is going to heat up, and you're potentially going to fry your Arduino if you have a short circuit like this. So it's important whenever you're setting up a circuit to think about making a complete circuit and always having some sort of resistance between power and ground. Okay, that is all. See you in class tomorrow.